Alright, so in this video, I'm going to solve the problem 5 to the power of 11 minus 3 to the power of 2. So I want to find the value of this problem. So what many people try to do to solve this is they first start by trying to take the power of 5 to the power of 11. But this is difficult because you have to multiply 5 by itself 11 times, and that's going to be a very big number. So instead of doing that, I have another method to solving this. So first, I'm actually just going to solve 3 squared, which is simple. It's 9. So this turns into 5 to the power of 11 minus 9. Now, from here, I'm going to rewrite 5 to the power of 11 as 5 to the power of 10 plus 1. This way, I can use the property a to the power of m plus n is equal to a to the power of m times a to the power of n. So now this turns into 5 to the power of 10 times 5 to the power of 1 minus 9. Now, from here, I can factor out 5 from this. So I get 5 times 5 to the power of 10 minus 1 minus 4. And this turns into 5 times 5 to the power of 5 times 2, which I'm rewriting 5 to the power of 10 as minus 1 minus 4. Now another property of exponents that you guys should remember is that if you have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 5 to the power of 5 times 2, I can rewrite as 5 to the power of 5 to the power of 2. And I have this minus 1 minus 4. Now, I'm going to rewrite 1 here as 1 squared. And the reason I'm doing this is so I can use the property a squared minus b squared is equal to a plus b times a minus b. So notice how we have a squared, which in this case a is 5 to the power of 5, minus b squared, which in this case b is 1. So it turns into 5 times 5 to the power of 5 plus 1, which is a plus b, times 5 to the power of 5 minus 1, a minus b. And then we have minus 4 at the end. Now earlier, remember we had 5 to the power of 11, which was quite difficult to solve, but now we have 5 to the power of 5, which is actually much simpler to solve because it's just 5 multiplied by itself 5 times. 5 times 5 is 25, so I have 25 times 25 times 5, which is 625 times 5, which is 3,125. So I get 5 times 3,125 plus 1 times 3,125 minus 1 minus 4. Now all that's left to do is to simplify this. So 3,125 plus 1 is 3,126. And 3,125 minus 1 is 3,124. And then we have minus 4 at the end. So the main challenge right now that we have is multiplying 3,126 with 3,124. What we could do is multiply the normal way, which is like this. However, this is going to take very long and it could result in many errors because there's several steps in doing this. So instead, I'm going to do another method that's much simpler and more efficient. So what I'm going to do is rewrite 3,126 as 3,100 plus 26. This way we have a simpler number because it ends in a 0. And same with 3,124. I'm going to write it as 3,100 plus 24. So this way, to multiply these, I can just distribute, and there's no real challenge in multiplying any of these numbers because the larger numbers end with 0. So now I get 5 times and what I'm going to do again is rewrite 3,100 as 31 times 100. So now it's just even smaller. So I have this plus 26. And now what I'm going to do is I'm going to use substitution. So I'm going to let the variable u equal to 100. So now I get 5 times 31u, 31 times u, plus 26 times 31 times u plus 24 minus 4. So now, if I distribute over here, I get 5 times 31u times 31u plus 31u times 24 plus 26 times 31u plus 26 times 24. And then we have minus 4 at the end. Okay, so now I'm going to multiply all of these. So I have 5 times, well, 31 times 31 is 961, and u times u is u squared. Now 31 times 24 is 744, and we have u over here, plus 26 times 31 is going to be 806, and we have u, plus 26 times 24 is 624. Now I'm going to add these two since they're like terms. So I get 5 times 961u squared plus 1550u plus 624 minus 4. And now I'm going to multiply all these terms with 5. So 5 times 961 is 4,805, and we have u squared. 5 times 1550 is 7750u. Finally, 5 times 624 is 3,116. And then we have minus 4 at the end. Or sorry, it's 3,120, and then I have minus 4, which turns into 3,116. Now, the last step is to just plug in the value of u. So remember, u is equal to 100. So it's not that hard to just plug it in because all we have to do is work with hundreds, and multiplying hundreds is simple. 100 squared is 10,000. So I have 4,805 times 10,000, which we can just add 4 zeros to the end of. So now I get 48,050,000 plus 7750 with 2 zeros, which turns into 775,000 plus 3,116. And now if I add all of these up, 48,050,000 plus 775,000 plus 3,116. I have 6 over here, 1, 1, 5 plus 3 is 8, 7 plus 5 is 12, 7 plus 1 is 8, 8, 4. So my final answer of 5 to the power of 11 minus 3 squared is 48,828,116. Now, if you haven't already, please make sure to subscribe, leave a like, and share this to any of your friends or family. Thank you.
Alright, so in this problem, I have x to the power of y minus y to the power of x is equal to 17. So, to solve this problem for my solution, I'm going to first, let me rewrite the equation right here. Now to start, just by looking at this equation, what can we infer? Well, notice how we have x to the power of y minus something is equal to 17. And 17 is greater than 0, right? Meaning, x to the power of y is greater than y to the power of x. And this also must mean that x is greater than y, and y is greater than 0. So now that we know this, I'm going to rewrite my equation here, x to the power of y minus y to the power of x is equal to 17. And x to the power of y, I can rewrite this as x to the power of y to the power of 2 over 2, because 2 over 2 is the same thing as 1, and x to the power of y to the power of 1 is the same thing as x to the power of y. Now this I can rewrite as x to the power of y over 2 to the power of 2. Because if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n, so I can switch these up. Now, y to the power of x, I can also change this up as well. So y to the power of x, I can rewrite that as y to the power of x to the power of 2 over 2. And this I can rewrite as y to the power of x over 2 to the power of 2. Now from here, remember my original equation was x to the power of y minus y to the power of x equals 17. Now I can replace x to the power of y with x to the power of y over 2 to the power of 2, and y to the power of x with y to the power of x over 2 to the power of 2. So now I get x to the power of y over 2 to the power of 2 minus y to the power of x over 2 to the power of 2 is equal to 17. Now I'm going to let x to the power of y over 2 equal to the variable a, and y to the power of x over 2 equal to the variable b. So now, if I substitute in a for x to the power of y over 2 and b for y to the power of x over 2, I get a squared minus b squared is equal to 17. Now, if I have something in the form x squared minus y squared, this is equal to x plus y times x minus y. So a squared minus b squared, that's going to equal a plus b times a minus b is equal to 17. Now the only factors of 17 are 1 and 17, meaning that one of these two has to be 17 and the other one has to be 1. So just by looking at this, we can tell that a plus b is going to be 17, and a minus b is going to be 1 because a plus b is greater than a minus b. Meaning, I have two equations, a plus b equals 17, and a minus b is equal to 1. So now what I'm going to do is I'm going to add these two equations together. A plus a is 2a, b minus b is 0, so these two cancel out, and 17 plus 1 is 18. So I get 2 equals 18, and if I divide both sides by 2, I get a is equal to 9. Now I can plug back in a for 9 into my original equation. So we could just do either one. I'm going to do a plus b equals 17. If I plug in a for 9, I get 9 plus b equals 17, meaning b is equal to 8. So a equals 9, b equals 8. And we can even check it over here. Let's plug both of these in. A is 9 minus b is 8, and 9 plus 8 does equal 1. So now that we know a is 9 and b equals 8, we can go back here and notice how we let x to the power of y over 2 equal a and y to the power of x over 2 equal b. Meaning, x to the power of y over 2 is equal to 9, and y to the power of x over 2 is equal to 8. So, to solve this, let's first start by solving the first equation. So x to the power of y over 2 equals 9. I can first start by taking the power of 2 on both sides. So then these two cancel out, and I get x to the power of y is equal to 81. Now 81, I can rewrite that as 3 to the power of 4. Now I'm going to do the same thing to y to the power of x over 2. I'm going to take the power of 2 on both sides, and then these two cancel out, so I get y to the power of x is equal to 64. Now 64, I can rewrite that as 4 to the power of 3. So I have x to the power of y equals 3 to the power of 4, and y to the power of x equals 4 to the power of 3. Well, what does that mean? Well, y 4, x 3, and over here, y 4, x 3, meaning x is equal to 3, and y is equal to 4. So this is my solution to this equation.